Welcome back to our series on linear equations. Last time we introduced the Cartesian coordinate system and plotted coordinate pairs, then connected the dots and found the slope. If you missed that, check out that video in the link below. We calculated the slope was m equals 1/2, all right? I'll put that there for reference. Today we're going to talk about the point slope form. Okay, so as the name implies, we need a point and the slope. Well, we just calculated the slope and we have a choice between 2 points. So I'll start with the left-hand point. Before we get there, remember m, the slope, is equal to y2 minus y1 over x2 minus x1. Well, if I drop the subscript 2, all right, just make this a generic y and generic x, but I keep x1 and x2 because I'm referring to this point. Okay, doing some algebra, I'm going to multiply both sides times x minus x1, right? So if I do it over there, I have to do it over here. So this will cancel, and I'm left with, well, y minus y1. So if I add a y1 to both sides, well, then these are going to cancel, and I'm left with what? Y equals m times x minus x1 plus y1. I know m, so let's solve. Y equals, m is 1/2, okay. X is our variable, minus a -1 is +1, and then y1 is the +1. Okay, good deal. I can distribute this 1/2 to both terms, so y is equal to 1/2 x plus 1/2 plus 1. Well, 1 can be rewritten as 2 divided by 2. So anything divided by itself is equal to 1. 1 plus 2 is 3, and we keep the denominator. So y is equal to 1/2 x plus 3/2. I just used point slope form to derive what is called slope-intercept form. So as this name implies, it involves the slope of a line and its y-intercept. So in this case, y equals m, you'll see this often, y equals mx plus b. So m is 1/2, right? That matches our previous finding. B is what we call, this is the y-intercept. Where does the line intersect the y-axis? 3/2. 3 over 2, it's 1.5. That's between 1 and 2. Looks like it matches up quite well on our graph. Let's go back to point slope form, and we're going to plug in this coordinate. So instead of this coordinate, I'm going to plug in this one. Yeah, this here is important. This here is important. So back here to y equals m times x minus x1 plus y1. Well, I'm changing the subscript x2 and y2. So y is equal to, slope is still the same. Now x2 is going to be 5 this time, and y2 is going to be 4. Okay, I've just plugged it in, x2, y2. Now I can distribute the 1/2. 1/2 x minus, well, 5 times 1/2 is 5 over 2, plus 4. Okay, well, 4 can be expressed as 8 over 2. So we have a common denominator. -5 plus 8 is 3. And we have y equals 1/2 x plus 3/2, which matches our answer here. So in short, that shows you, once you find the slope, it doesn't matter which point you select on the line. You know, you could even pick a point up there, down here, anywhere along the line. As long as you have the slope and the line and your numbers are correct, you will get the same answer for slope-intercept form. Point-slope form requires one coordinate pair and the slope. Slope-intercept form requires the slope and the y-intercept. So both require 2 pieces of information. In the next lesson, we will talk about a third form. So stick around for that. I'll see you then.